Let's analyze whether there's sufficient capacity in a main electrical panel to add a 70 amp subpanel. We'll start by examining the existing circuit load. There are 6 circuits at 15 amps each, which totals 90 amps. There are 7 circuits at 20 amps each, totaling 140 amps. There are 3 circuits at 30 amps each, totaling 90 amps. There is one 40 amp circuit and one 50 amp circuit, totaling 90 amps. Adding these together, 90 amps plus 140 amps plus 90 amps plus 90 amps, the total existing load is 410 amps. Now, let's determine the remaining capacity. The main panel amperage is 150 amps. The existing load is 410 amps. The remaining capacity is calculated by subtracting the existing load from the main panel amperage, which is 150 amps minus 410 amps, resulting in negative 260 amps. Based on these calculations, there is not enough remaining capacity in the main panel to safely add a 70 amp subpanel. The existing load exceeds the capacity of the panel, indicating that it's already overloaded. Now, let's explore some possible solutions. Firstly, consider upgrading the main panel to a high amperage. This would increase the available capacity and allow for the installation of the subpanel. A licensed electrician can assess the service entrance and determine the appropriate panel size upgrade. Secondly, reduce the load on the existing circuits. This could involve several strategies. One option is turning off unused circuits. Another is replacing high current appliances with more energy efficient models. A third option is adding additional circuits to distribute the load more evenly. Consult with a qualified electrician to evaluate the existing circuit layout and determine the best approach. Thirdly, consider installing a smaller subpanel. Instead of a 70 amp subpanel, consider installing a 50 amp or 60 amp subpanel. This would reduce the load demand on the main panel and potentially allow for installation without exceeding its capacity. It's also worth noting that number 4/3 cable is an appropriate wire size for a 70 amp subpanel. However, always consult the National Electrical Code and local regulations for specific requirements. It is essential to install a grounding rod at the subpanel to provide a proper ground path. This helps ensure electrical safety and protects against potential hazards. Remember, electrical work can be dangerous. It is always best to consult with a qualified and licensed electrician for any electrical installations or modifications to ensure safety and compliance with all applicable codes. A licensed professional can accurately assess your electrical needs, perform the necessary calculations, and safely install the subpanel while adhering to all safety regulations. Furthermore, they can identify any potential hazards or code violations and provide recommendations for addressing them. Remember to always prioritize safety when working with electricity. Always turn off the power at the main breaker before working on any electrical circuits. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are unsure about any aspect of the electrical work, seek professional assistance. Adding a subpanel to your electrical system can provide increased capacity and convenience, but it's crucial to ensure that the installation is performed safely and correctly. By following these steps and consulting with a qualified electrician, you can ensure a safe and reliable electrical system for your home or business. When calculating the load, it is important to consider not only the amperage of each circuit breaker but also the actual load that is expected to be drawn on each circuit. For example, a 20 amp circuit breaker may only be used to supply a few light fixtures that draw a small amount of current. In this case, the actual load in the circuit may be much less than 20 amps. To accurately calculate the load, it is necessary to determine the wattage of all the devices that will be connected to each circuit and then divide the total wattage by the voltage of the circuit. This will give you the actual amperage that is expected to be drawn on the circuit. It is also important to consider the potential for future load increases. If you plan to add more devices to a circuit in the future, you should factor this into your load calculation. It is always better to overestimate the load than to underestimate it. If you underestimate the load, you may overload the circuit, which can cause the circuit breaker to trip or even start a fire. When choosing a subpanel, it is important to select one that is appropriately sized for the expected load. The subpanel should have enough circuit breaker spaces to accommodate all of the circuits that will be connected to it. It is also important to choose a subpanel that is rated for the appropriate amperage. The amperage rating of the subpanel should be equal to or greater than the amperage of the main breaker that will be supplying it. When wiring the subpanel, it is important to use the correct wire size. The wire size should be appropriate for the amperage of the circuit. Using undersized wire can cause the wire to overheat, which can lead to a fire. It is also important to properly ground the subpanel. Grounding the subpanel helps to protect against electrical shock. The grounding wire should be connected to a grounding rod that is driven into the ground. When installing a grounding rod, it is important to drive it deep enough into the ground to ensure that it makes good contact with the earth. The grounding rod should also be located away from any underground utilities. It is also important to properly bond the subpanel to the main panel. Bonding the subpanel to the main panel helps to ensure that the two panels are at the same electrical potential. The bonding wire should be connected to the grounding bus in both the subpanel and the main panel. When connecting the wires to the circuit breakers, it is important to tighten the screw securely. Loose connections can cause the wires to overheat, which can lead to a fire. It is also important to make sure that the wires are properly insulated. Damaged insulation can expose the wires, which can create a shock hazard. Before turning on the power to the subpanel, it is important to inspect all of the wiring to make sure that everything is properly connected and insulated. It is also important to test the circuits to make sure that they are working properly. You can use a multimeter to test the voltage and amperage of the circuits. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install the subpanel. Electrical work can be dangerous, and it is important to take all necessary precautions to avoid injury. Remember to consult the National Electrical Code, or NEC, and local regulations for specific requirements and guidelines related to electrical installations. These codes provide detailed information on wiring methods, grounding, overcurrent protection, and other safety aspects of electrical systems. Adhering to these codes is crucial for ensuring the safety and compliance of your electrical installation. A qualified electrician will be familiar with the NEC and local regulations and can ensure that your subpanel installation meets all applicable requirements. Furthermore, a professional electrician can perform a load calculation to determine the actual load on your existing circuits and the appropriate size subpanel for your needs. They can also assess the condition of your existing electrical system and identify any potential hazards or code violations. In addition to installing the subpanel, a qualified electrician can also provide advice on energy efficiency and help you choose energy-efficient appliances and lighting fixtures. This can help you save money on your electricity bills and reduce your environmental impact. When choosing an electrician, it is important to select one that is licensed and insured. A licensed electrician has met the requirements of the state or local government and has demonstrated their knowledge and skills in the electrical field. Insurance protects you in case the electrician damages your property or causes an injury while working on your electrical system. It is also a good idea to get multiple quotes from different electricians before making a decision. This will allow you to compare prices and services and choose the electrician that best meets your needs. Be sure to ask the electrician for references and check them before hiring them. A reputable electrician will be happy to provide you with references from satisfied customers. Finally, be sure to get a written contract from the electrician before they start work. The contract should specify the scope of the work, the price, and the payment terms. It should also include a warranty on the work. By following these tips, you can ensure that your subpanel installation is performed safely and correctly and that you are protected from potential problems. Remember that electrical work can be dangerous, so it is always best to err on the side of caution and seek professional assistance if you are not comfortable working with electricity. A qualified electrician can provide you with the expertise and experience needed to ensure a safe and reliable electrical system for your home or business. Let's delve further into the electrical load calculations. When assessing the existing load, it's not just about adding up the breaker ratings. Breaker ratings indicate the maximum current a circuit can handle before tripping, but the actual load might be lower. For lighting circuits, consider the actual wattage of the light bulbs or fixtures connected. For appliance circuits, check the appliance's nameplate for its power consumption in watts or amps. If the nameplate lists watts, divide by the voltage, typically 120 volts in residential settings, to find the amperage. For motors, like those in refrigerators or air conditioners, consider the starting current, which is often significantly higher than the running current. The National Electrical Code, or NEC, allows for demand factors to be applied in certain situations. A demand factor is a percentage that reduces the calculated load based on the assumption that not all appliances or lights will be used simultaneously at their maximum rating. For example, the NEC allows for a demand factor of 0.75 or 75% to be applied to the portion of a dwelling unit's lighting load that exceeds 3 kilowatts. This means that if your calculated lighting load is 5 kilowatts, you can apply the demand factor to the portion exceeding 3 kilowatts, which is 2 kilowatts. 75% of 2 kilowatts is 1.5 kilowatts, so the adjusted lighting load would be 3 kilowatts plus 1.5 kilowatts, totaling 4.5 kilowatts. Consult the NEC for specific demand factors applicable to different types of loads. When considering a panel upgrade, it's essential to evaluate the service entrance conductors. These are the wires that bring power from the utility company to your main panel. The size of these conductors must be adequate to handle the increased load of the upgraded panel. A licensed electrician can assess the size of your service entrance conductors and determine if they need to be upgraded as well. If the service entrance conductors are undersized, they can overheat and cause a fire. In addition to the service entrance conductors, the grounding system must also be adequate for the upgraded panel. The grounding system provides a path for fault current to flow back to the source, which helps to protect against electrical shock. A licensed electrician can inspect your grounding system and ensure that it meets the requirements of the NEC. When installing a subpanel, it's important to choose a location that is easily accessible and has adequate ventilation. The subpanel should not be installed in a damp or wet location, as this can create a shock hazard. The subpanel should also be mounted securely to a wall or other structural member. The NEC specifies minimum working clearances around electrical equipment. These clearances provide enough space for electricians to safely work on the equipment. Be sure to comply with these clearance requirements when installing the subpanel. When running the wires from the main panel to the subpanel, it's important to use the correct wiring method. The NEC specifies different wiring methods for different applications. For example, you may need to use conduit to protect the wires in certain locations. When connecting the wires to the circuit breakers in the subpanel, be sure to use the correct torque. The torque is the amount of force that is applied when tightening the screws. Using too much torque can damage the circuit breaker, while using too little torque can cause the connection to loosen over time. The circuit breakers in the subpanel should be sized appropriately for the circuits that they will be protecting. The breaker size should not exceed the ampacity of the wires that are connected to it. Overcurrent protection is crucial for safety. Circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a safe level. This prevents the wires from overheating and causing a fire. It is important to choose the correct size circuit breakers or fuses for each circuit. The NEC provides tables that specify the ampacity of different wire sizes. The ampacity is the maximum current that a wire can safely carry. Table 310.15 is a crucial table in the NEC. Always consult these tables when selecting wire sizes and circuit breaker ratings. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. Bonding connects all of the metal parts of the electrical system together, which helps to ensure that they are at the same electrical potential. The grounding electrode system typically consists of a grounding rod, a grounding wire, and a connection to the metal water pipe. The grounding rod should be driven at least 8 feet into the ground. The grounding wire should be connected to the grounding rod and to the grounding bus in the main panel. The metal water pipe should be bonded to the grounding bus in the main panel. Surge protection is another important aspect of electrical safety. Surges are sudden increases in voltage that can damage electronic equipment. Surge protective devices, or SPDs, can protect against surges. SPD are typically installed at the main panel and at subpanels. Arc fault circuit interrupters, or SIs, are another important safety device. SIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. SIs are required in many locations in homes, such as bedrooms. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which are electrical conditions that can cause electric shock. GFCIs are required in locations where there is a risk of water exposure, such as bathrooms and kitchens. Remember to consult the NEC and local regulations for specific requirements and guidelines related to electrical installations. These codes provide detailed information on wiring methods, grounding, overcurrent protection, and other safety aspects of electrical systems.